a manifold system. Okay, it's fully sales certified by itself, whether it's one out of two, two out of two, or two out of three. They come in two sizes for different requirement itself, whether it's a high flow or standard flow, two pot size. Now, what I wanted to highlight is the configuration is as such that the solution is very easy to connect. There's only one inlet, one outlet, despite the complex of the schematic drawings. So you won't get it wrong. And every point, there will be a visual indication by itself, and you can see that every visual indication, for example now, one of the solenoid valve has failed, it turned red. What you have to do is do a bypass. Remove this and replace the solenoid valve. Now, I just want to highlight, throughout all this exchange or replacement of the solenoid valve, your process plant is still in operation. You do not need to stop your process valve. You do not need to interrupt your production, but you can replace the faulty solenoid valve. A simple way to put it is, when we drive a car, we all have a spare tire in the booth. Now, if you have a puncture tire, you need to stop the car to replace the tire, right? But how about this? You can continue to drive your car, replace your puncture tire without stopping your car. This is exactly what it is trying to say. Okay? You can keep the plant going without shutting it down, and then you replace the faulty component. After you switch back the bypass, and then life goes on as normal. Okay, let me stop this. All right. Now, on top of that, all these components, all the solenoid valve or components that we supply in the redundancy system complies to international standard, be it IEC, ATEX, or the respective local requirement, like in China, we're talking about CCC, CSA, or KOSHA, TS in Taiwan, so on and so forth. All the electrical component comply to international standard as well as respective country requirement as well. Some of the installation or typical that we have in the past for Asia Pacific itself, you can see that we have a fair amount of installation in LNG facilities, chemical plant, industrial gas. Even in China, coal to gas installation as well. Basically, any process, especially the critical one that they do not want the outcome of dangerous failure, they cannot tolerate, or they don't want the outcome of undesirable, unplanned shutdown. They want to guard against all this. Redundancy have a place for it. Sorry, too fast. Okay, next one. Besides redundancy and backup system, we are also talking about rigorous testing. That is also another method to guard against risk in the process industry. Now, what is the meaning of a partial stroke testing? Basically, a partial stroke testing is most of the installation in the process, the valve will stay in the same position for a long time. After a commissioning, it will stay in the same position for maybe 2 years, 3 years until the next turnaround, next shutdown. Then you have a chance to move the valve. But if you leave, like all mechanical product or design, if you leave anything in the same state for too long, there's always a fear that if there is a demand, if there is a requirement, the valve is not able to go back to its fail-safe position. So the purpose of a partial stroke basically is you wanted to flex the muscle, move the valve a little bit, just a little bit to break the torque, but not too much to shut down the process. So that is what we meant by partial stroke. So you have a comfort feeling that if I send a signal, the valve will move a little bit, and then you'll go back to its fully open or functional position. So I know that in the event if I need to stroke it to close, it will be able to close. Okay. Now the purpose of a partial stroke, besides the redundancy, to talk about the risk management part of it, is also to talk about prolong the in-between shutdown. Now we talk about the risk first. Some of the risks that we can big disastrous outcome. Maybe the first two is very far away from us. 1984, Bhopal in India, the leakage of the toxic gas killed 20,000 people around the village, outside the plant itself. These are innocent life. We are talking about 40 years ago. Maybe we don't have, many of us here may not have the strong collection about what happened that time. But what about 2010, the Gulf of Mexico? That is something I think many of us here today here may have some idea. The whole platform was burned down, and the spill of the oil that goes into the Gulf of Mexico take years to clear. The impact to the environment is terrible. Okay, so these are some of the failures of the instrumentation side, control side, that actually have a very impactful outcome in the negative way. Now, so besides managing the risk itself, one of the good things about partial stroke testing is you can actually, by going through a partial stroke, prolong the in-between shutdown period. Now, a lot of time, besides guarding against the risk, we want to make sure we maximize the operation. We want the plant to run as long as possible. In the past, it's 4 years in between shutdown. We want to do it 5 years. Can we do it 6 years later or even longer? In order to do this without compromising the risk, you need to have some strategy to mitigate the risk. So one of them is to do a partial stroke testing. By stroking the valve, you know that, okay, after 4 years, I know this valve still behaves the way that it's supposed to design to do so. I have a comfort feeling that I can continue to run my plant without worry. Actually, there are more to it. We'll talk a little bit about this later on. Basically, the working principle of a partial stroke testing device is when we do a quick stroke, maybe a 5-10% of stroke of the process valve, we actually capture some of the key parameters. We capture things like the pressure, the position, as well as the time, how long it takes for the pressure to decline, how long it takes for the position to switch. Okay, on the extreme right side, you see a graph. Okay, the red light. The red line and the green line are basically is a signature graph of the full stroke, from fully open to fully closed. We know exactly when the signal comes for it to shut down, how long does it take to shut down completely, from fully open to fully closed. At what point of time, what is the position, what is the pressure signature. And over time, 6 months, 1 year down the road, if we were to do a partial stroke without shutting down the process totally, we also capture the same type of information and we compare that with the signature graph. From there, we know how much is the deviation. From there, we have a better idea what is the working condition of the process valve itself now. Now, the good thing about doing a partial stroke, it actually gives you a good diagnostic coverage, not just on the solenoid valve itself. More importantly, you know what is the health condition of the process valve, what is the health condition of the actuator, as well as the instrumentation side of it. So it gives you a full spectrum of the coverage of the whole, what we call the final element itself. And with all the data points that we have collected, it actually provides you a lot of insight on the analysis of your installation as well. And the operator can make an informed decision whether the next shutdown, are they going to service the valve or they're going to skip it because it's still as good as new, they keep it to the next time. Okay, some of the key features. This partial stroke testing device that we have, or sometimes we conveniently call it a smart solenoid valve, is the only solenoid valve in the market today that is capable of doing partial stroke testing. There are other strategy or other solution offered by other vendors. That normally involves a lot of components, engineering, calculation to put down a lot of components together to achieve the partial stroke testing. We won't be touching about the alternative solution in the market, but this is the only one in the market today that's able to do partial stroke testing. They have the best in class in terms of sales functional data. We're talking about lambda D, as in the dangerous failure of 5 failures in every 1 billion hour of operation. And the safe failure, we're talking about lambda S of 31 case of failure in every 1 billion hour operation. If you compare this against the industrial standard, this is considered one of the best in class in the market. Excuse me. Okay, some typical installation of the partial stroke testing device. We have installed them in the onshore processing plant in Indonesia. We have installed them in one of the platform operator. We have formed an agreement with them that they will retrofit all the rigs that comes back for retrofit, and has been doing it for the last 6-7 years already. Today we're talking about a few hundred rigs using this device. Refineries. The picture that we show here is a refinery in Taiwan itself that uses this solution. And we also have HIP system in Russia. In this case, the picture here is Russia in Scaling Island that uses a HIP system that uses a partial stroke testing as well. So with this is more or less the last slide I will share. Besides the two products that I have mentioned or shared with the team here, they are also, we as a company, as an instrumentation company, we also have a full suite of instrumentation to share or to offer a solution to the market as well. Before I go, is there any question for me? Okay, in that case, thank you very much.